Hi, in this tutorial we are going to solve a question related to naming of aldehydes and ketones. The question asks us, give IUPAC names for the following compounds. Let's start from the first structure. If you look at the first structure, we can see that this is a ketone, and here we have a carbonyl part, and both part is carbon-carbon, so it's a ketone. And we have here an alkene functionality. Here we have a substituent. Let's write the names for each part. So the first thing we have to do, this is a ketone, and this is an alkene, and this substituent, let's circle it, it is isopropyl. Okay, let's look at, this is a ring. It is a 5-membered ring, so it is cyclopentane. And when we have a ketone, we say cyclopentanone. Okay, since we have pentanone, since we have an alkene here, we have to say cyclopentanone, and we have to specify the location. So let's start numbering for this ketone. We always know that when we have ketones in cyclic structures, or ketones related to cyclic structures, we have to start numbering the carbon of carbonyl carbon 1. Then I will go this way, because when we go this way, we will have 2, 3. That's right, 2, 3, and from the other side 2, 3 alkene, but the isopropyl substituent will be at the 3rd position. But when you go from this side, let's just use another color, let's say blue color. So this will be 2, this will be 3. The alkene position will be the same, but the isopropyl will be at the 4th position. So the choice will be going right side this way for the numbering. So let's write the name. We have here 3. At 3 we have isopropyl, and then this is a cyclopentane or cyclopentene, and the location of double bond is 3, or location of the alkene functionality is 3. So let's say this is isopropyl. Then we have to say that the location of double bond is 3 in, then the location of ketone is number 1 on. So basically we follow the new IUPAC guidelines to name this molecule. So this is 3 isopropyl cyclopentanone, and we have to say 3 in, because the location of alkene is 3 and the location of ketone is 1. When you have 1, you don't have to say, or you don't have to specify 1. So if you write cyclopentanone, it's going to be also a correct naming. So let's move to the second molecule. Let's see. Let's here look at the carbonyl part. The carbonyl carbon has 2 connections. One is hydrogen here, one is carbon. So this is going to be an aldehyde. So let's write here, this functionality is an aldehyde. So we have here an alcohol functionality, So when we do naming, or when we write the name for this molecule, so aldehyde functionality will predominate over alcohols, but we have to specify them also. Another thing, so we can see here the let's number the carbons. So this is number 1. Carbonyl carbon is number 1 in aldehydes all the time. So this is the 2nd carbon, this is the 3rd carbon. 2nd carbon is a chiral carbon, so we have to designate R or S configuration for the 2nd carbon. So for that reason, let's just use another color. Let's say blue, and let's say which configuration is this. We know that according to Kahn-Ingold-Prelog sequence rule, hydrogen is always number 4. Oxygen, carbon, carbon, so this group is going to be number 1. And carbon, carbon, this carbon has a double bonded oxygen, this carbon has a single bonded oxygen, so this will have like priority over this, so it's going to be number 2, and this carbon is going to be number 3 in the sequence route. So let's look at which way we go from 1 to 3. So 1, 2, and 3. So this is clockwise, and we are going to say when it is clockwise R, but when you look at hydrogen, number 4 is coming out of the plane, so you have to say the opposite. So if it is clockwise and hydrogen is coming out of the plane, it has to be S. So basically this chiral center, let's just use an asterisk, it's S configuration. Okay, so basically when we write the name for this molecule, we have to start writing in parentheses the location and the configuration. So let's say second carbon is S, right? So in parentheses 2S. You don't have to put also like 2 or parentheses, because we have only here one chiral center. But as a rule, let's keep this way, 2S. Then this we have 1, 2, 3, so it is propane, it's propanol, and we have to say OH and OH. So at the second and third carbon we have hydroxy groups. So let's write it is 2, 3 dihydroxy. This is this is 1, 2, 3, so it's propane. It is propane, E will drop, then we have to add L suffix, propanol. So 2S dash 2, 3 dash dihydroxy propanol. Let's move to the third one. Third one is it's very recognizable. This is a benzaldehyde, and let's write the numbers. So 1, 2, 3, 4. At the fourth position we have chlorine, but you remember IUPAC suggests that you use ortho, meta, or para for disubstituted benzene ring. So we are going to use 1, 4, so it has to be para. So let's write the name for this molecule. It is para-chlorobenzaldehyde. Let's write here, I will abbreviate as P, para-chlorobenzaldehyde. It's the common name, benzaldehyde is the common name, but if you would like to write another name, you can say that this is benzene. So if you have aldehyde, benzene, carbaldehyde, this is 4, right? Let's say, or 4, or let's, since we are using benzene, let's use para-chlorobenzene carbaldehyde. IUPAC also accept this way. Okay, let's move to the last structure. Last structure is a ketone. We have a carbonyl functionality here, and both part is carbon-carbon, so an alkyl substituted. So we say this is a ketone, and for the ketones we have to start numbering from the end nearer to the carbonyl part. So let's find the longest chain. So if we start from here, 1, 2, 3, 4, 5, 6 carbon is the longest chain. So we are going to start from the left end, because carbonyl is closer to the left end. So that's the rule. So 1, 2, 3, 4, 5, and 6. So this is hexane, hexanone, but at the fourth position we have methyl, and the location of ketone is 3. So we have to specify both the location of ketone and the location of this substituent. So let's write the name here. So we have 4-methyl. So I'm going to write it over there. So the last one, 4-methyl. And I'm going to use both old and new system. So old system says that you have to specify the location before the parent. So 3-hexanone, E will drop, we will add on. Or you can write similarly 4-methyl hexane 3 on. So this is the newer system, this is the old system. Thank you so much for watching this video.